So here's the point 2, 1. And here's the point 2.1, 1.2. So to get from here to here, we've got to go over this far and up this far, right? 0.1 unit and 0.2 unit. Okay? Well, in the x direction, the rate of change of z it is at this point exactly 4. Now I say it's approximately 4 because as soon as we move away from this point, the rate of change changes. Okay? And the rate of change of z with respect to y is approximately 12. Right? Again, that changes as soon as we move away from the point, whether we move to the right or the left or up or down. The rate of change, which is given by this expression or this expression, is going to change. But x and y aren't changing by a whole lot. So we're going to say if these changes are small enough, then we're going to get a good approximation if we just assume that the rate of change stays at 4. Okay? And that this rate of change stays at 12. Okay? So if this rate of change is 4, well, delta x as we go from this point to this point is what? It's the change in the value of x, right?
Yeah, so would it just still be 4? Or are you just saying it like 0.1?
It's 0.1, yeah.
Okay, yeah.
That's the change in x,
Okay.
okay? Change in x is 0.1. The relevant rate of change to a change in x is 4, meaning that the value of this function changes by 4 units for every x unit. Well, that means that and the rate of change is approximately 4. Let's make sure we remember that this is an approximation. So the rate of change of z is just 4 delta x, which is 4 times 0.1, which is 0.4. Now that's as we go from here to here, right? Of course, now we're also going to have to move up here. So here, delta y is about 0.2. So, what do we conclude? Delta z for a move in this direction should be approximately 12 times 0.2. You know, a change of 12 per unit of change in y, but only a 0.2 unit change, and that would be 2.4. Okay? Now again, since we're going along this line and then along this line, this rate of change is probably not going to be as accurate as this one, but we're going to say this is only an approximation. We're just trying to get an idea of how much this changes, and then pretty quickly we're going to change it with the actual change, or compare it with the actual change. Okay? So, and it's 2, 1, not 1, 2. We get about 0.4 units of change because we're moving in the x direction. and we're getting about 2.4 units of change for our motion in the y direction. So we expect a change of about 2.8. Well, since f of 2,1 equals, calculated it earlier, right? F of 2,1 is 4. No, that's right. Okay. F of 2,1 is 4, right? So f of 2,1, 1.2 should be about what?
6.8.
Yeah, 4 plus 2.8. Did you say 6.8? I heard part of that, and I figured the rest of it was exact. Yeah, the part that I heard sounded right. Okay, so 6.8, right? Well, actually, f of 2.1, 1.2 is closer to, well, let's see, 2.1 squared is 4.41. And 1.2 cubed is, I should be able to do that, 1 plus 0.2 cubed, okay? It'll be 1.6, working memories of abandoning me. I'm just using the binomial expansion, okay? 0.04 times 1, 1.64. Now, if I multiply that by 4.41, I don't know what I get. But, 4 times 1.6 is 6.4. Okay, the 1 doesn't make much difference. Well, you can figure it out in your calculator. Equals what? Should be close. Of course, this is accurate. Okay, well, go ahead, punch it into your calculator. How close to 6.8? It's pretty close. But it's going to be somewhat low. I mean, reasonably close. This function's changing pretty quickly. What'd you get?
I got 7.6.
Yeah, 7.6, I can believe that.
Yeah.
Okay, so we get 7.6. Well, when I say close, well, close is kind of relative.
Yeah.
Because if you took the partial derivatives here,
Mm-hmm.
they'd be a lot bigger than this.
Yeah.
So as you move from here to here, the rate of change changes pretty rapidly. Okay?
It's a pretty good approximation.
Yeah, well, it's a reasonable approximation. Oh, darn, I went over 15 minutes. I'm going to have to split the darn video. That's a pain, but I'm going to be up here for a while. So. Okay. So, do we get the idea?
Yes.
Okay, so review that and read the first section. And I'll post a few problems where I ask you to do calculations like this for reasonably simple functions, okay? Just so you get the ideas. And, I'm going to ask you to draw pictures and stuff.
Okay.